I'm going to look at encoding immediate sources now. So in this MOV encoding table, we can see that there are basically all of these encodings down here that include an immediate value as their source. And we can see that they're basically split up into these two sections. So there's basically this section on the top here, which is MOV specifically into registers. And then this bottom section is a MOV into register or memory. And the register one actually has this exception where you can move an immediate 64-bit value, where usually you can only encode a 32-bit value. So this one down here, even though it's a 64-bit target, it only allows an immediate 32. So we're going to encode both of them because they both have different sort of attributes, I suppose. This one has the plus RX syntax in the instruction encoding, and this one has the /D syntax, where D is basically a digit between 0 and 7. So we saw this when we were reading the manuals before. And this plus R something syntax basically says that the register, because it's a register-specific destination, the register is actually encoded in the lower 3 bits of the opcode itself. So what we would do here is we'd say that if it's, if the destination should be encoded in the opcode, we'll basically be skipping the ModR M byte. So we don't need a ModR M byte for these, but we do need to fill the low 3 bits of the opcode with the destination register number. And it can still be extended by rex as well. And I think in this case, it will be rex.b, if I remember correctly. So we can extend with rex.b, but we need to skip the ModRM byte entirely and just put the register number directly in the lower 3 bits of the opcode. This /D syntax here basically means that when we encode the ModRM byte, we're only going to use the mod and the RM fields. So we're only going to use mod ORed with the RM field. Normally we would also OR the reg field of the register operand in here as well. But the difference here is basically that the D gives us the number for the reg field. So rather than the reg field providing us with an actual register number, it's just going to provide us with this fixed 0 to 7 digit. So the reg field might be providing, for example, in this case, it provides 0. So we would OR 0 into this mod RM. But there are other instructions where it says like /5 or something, and in that case, the reg field needs to return 5, basically. It can't change. And the purpose of this is to extend the opcode with extra functionality, or you'll see it in things like, I think the add instruction and the sub instruction are the same opcode, but depending on the extension that you use, that's what changes whether it's an add or a sub. So yeah, anyway, we'll get to these things. I'm pretty sure that add and sub are the same opcode. Maybe I'll go and look at that quickly now. So we got sub down here somewhere. Sub is here. So sub for, let's say, immediate 32 to RM32 is 81 with a /5 here. So we've got 81/5. And then let's just go and have a look at add quickly. So A to L, add. And yeah, so the same thing. This is immediate 32 to RM32. It's the same opcode, 81, but the extension is 0 instead of 5. So this /D means that the reg field is actually going to be, a fixed number to tell the CPU what the opcode extension is. So I'll stick with MOV for now. And yeah, we'll just start by generating some tests again. So let's go to test cases. So we'll do a MOV into, let's say, some registers. So we'll do byte. Maybe we'll do one normal register and then some problematic registers as well. So this is going to be a byte MOV, so we'll do 7F into here. This one is going to be, let's say this is BPL. This one can be SPL. We'll do R12B and R13B as well. So this covers all of the problematic registers and a normal register. Then we'll do memory access. Maybe we'll do the other sizes first. Okay, we'll do the other sizes first. So we'll say this can be AX, this one will be BP, SP, this one's going to be W and W. So these are going to be a 16-bit MOV. These ones can be 32-bit. So we got EAX, EBP, ESP, and these can be D suffix. And then in the case of a register, MOV is a special case where it allows a 64-bit immediate. So we'll change these to R and we'll remove the suffixes from here. Okay, let's just take these. So we'll just transform these into memory moves as well. So this is actually going to be, I'll need to annotate these. So this will be a byte MOV. This one will be a D-word. Oh, sorry, this one will be a word MOV. This one will be a D-word MOV. And this one will be a Q-word MOV, which is the special case. Oh, this one is memory access, so we don't get Q-word. This is just D-word. But that only applies to the immediate. So if we want to move into a Q-word space, we can still put Q-word there. That will give us the 64-bit destination, but we can only move a 32-bit immediate. So I just need to change all of these to the R versions. So we'll just copy all of these over. And then we'll do one more group which will have a scaled index, let's say. And the scaled index can be itself multiplied by 4. We won't bother with any kind of sort of transformations or anything here. So this will be a base plus the index, and then we can't use RSP here, so maybe we'll use something like R15. Okay. I think that should be enough tests. Let's just see if I've got all of this syntax correct. So we're going to assemble test cases and output to test cases. Okay, that looks fine. So then we'll end this as B64 test cases. Okay, so we'll just go and put all of these into the test file. Okay, I just need to fix this formatting. Oh, there's some more formatting to fix up here. Okay, so we need to fill out the operands now. So this is going to be a byte MOV into AX with. I need some way to create an immediate, so I'm going to create a new I function. So this will be 07F. And then I'll just copy these into each test. So this one's going to be BP, this one SP, this one R12, then there's R13. Okay, let's just copy these operands down. And I just need to change the immediate for all of these. So this is the 64-bit one. I think that is that too many Fs? Yeah. Okay, so we'll copy this one down. Okay, that's 32 bits. Then we got 16 bits. Okay. So these ones will be keyword. These ones are D-word. This one is word. Okay, let's just copy all of these down again. So the difference here is that the destination is a memory access. And then the difference in this one is that it's a memory access with a scaled index. So the scaled index is this one. And it's always x4. So here we've got a scaled index of AX, BP, R15, R12, and R13. So let's just see if I've missed anything. Okay, just undefined I. So let's just go and create the ability to, we just need to write in the ability to create these immediate operands. So we'll have some constructor function here called I. So this will take in a value, which will be an int 64, and it will give us an operand. So we'll create a new operand that we'll mark as being an immediate with the value. So we need an immediate flag. Okay, so now we can work on the actual generator. So the first thing to do is to get the correct opcodes, I think. So if we go to the generator MOV, so right now we're just sort of assuming that it's a MOV between register and RM. So let's go and look at the MOV instruction again. So this, so the register ones start at B0, and the RM ones start at C6. But this is only if the source is immediate. So I'm going to change the names of these variables from op1 to destination, and op2 can be source. So then we can just say, for example, that we'll do a switch maybe, because this depends on what the source is. So maybe we'll say in the case that source is immediate, we'll do something, and in the case that source is reg or memory, then we do something else. So we'll say opcode in this case is the one that we had before. And in the case of source being immediate, now it depends on what the destination is. So if the destination is a register, then opcode should be B0. And if it's not a byte, we want to add 8. Otherwise, if it's memory, then we'll start at C6, and we'll do the +1 as we did before. Okay, so we're at least getting the correct sort of starting opcode. This one, for example, has a B5 as the opcode. That's because this is a register destination, and in this particular case, we're actually we're looking for no ModRM, and the register is in the opcode. So maybe what we can do is say, so after we've decided which one is RM and which one is register, we need to do something with the we need to extend the opcode in that case. So if the source is immediate, or then that means that reg is going to be an immediate. So we're going to be looking at the RM, which should always be the destination one in this case. So we'll say, for example, if destination is opcode-extension, then we'll want to do an opcode or equals dst dot. What should we do? We do dst dot. Well, rm would give us the low 3 bits. So that would give us the register number in that case. And we'll also want to skip the ModRM if this is the case as well. So if DST is, let's see, if it's not an opcode extension, then we want to do the ModRM. So I need to take this opcode append out here and do it up above this. If we're not extending the opcode, then we want the ModRM to be encoded. And I need the flag for opcode extension. So maybe I'll just put this up here. So we have a B0, F7F and F8 at the moment. Let's see, we want to try and figure out if we've got B4. So this one is not doing it just yet. So we want B4, but we're getting B0 still. So opcode-extension. Oh, I need to actually put the flag on. So we'll say dst info. So in this particular case, we're going to say that we're the opcode extension. And now we get, so here we've got 44B0, and because we're the opcode extension, we're now skipping ModRM, and we correctly get B5 here as well, which is good. So now there's this problem of this rex prefix. I don't actually need the rex prefix in this case, so I wonder what's going on there. Let's go and have a look at the manual again. So we've got interpreting encoding. So this one is the plus RB syntax. So it indicated the lower 3 bits of the opcode byte is used to encode the register operand without a ModRM byte, so that's what we're currently doing. The instruction lists the corresponding hexadecimal value of the opcode byte with low 3 bits as 000. In non-64-bit mode, a register code from 0 to 7 is added to the hexadecimal value of the opcode byte. In 64-bit mode, it indicates the 4-bit field of rex B and opcode 2 to 0 bits field encodes the register operand. Okay, so I need to figure out what's going on with this rex prefix then. So right now we're getting byte. We shouldn't be falling into this because it's not marked as XL. Reg is extended, so currently we're getting 4. So that is rex, which is probably just coming from the fact that these lower 4 bits are set. And then we've got 4 again, so this is this one. So we've got WR-XB. So for whatever reason, R is being set. So that means that reg is extended. That's because reg at the moment is being treated as, so this is actually the immediate value. So we need to check that reg is actually not immediate. So if it's extended and reg is not immediate, now we don't get that rex prefix, so that's better. So this one is 40B5, we've got B5, so we're successfully extending the opcode with those lower 3 bits of the destination. So now we just need to get this immediate value. So immediates come after displacements. So we'll say if the destination is immediate, then we'll take the immediate value, which will be just this will be, source value. Then we want to do this based on the size. So we'll switch on the size. In the case of bytes, we can basically just append the immediate byte. And then in the other cases, we'll basically just do this little endian thing again. So for word, it's going to be 16 bits immediate. Then we got D word, which is 32. And then we've got Q word, which is normally going to be 32. But in special cases, we allow 64. So we actually need 2 here. We need to be able to say that we want to append 64. this would be, for example, if let's say if the destination is allowed immediate 64, so we'll mark it with a flag to say that it's allowed. Otherwise, we'll do 32. So we need that flag. We'll say allowed immediate 64. And so when we've got a source of immediate and the destination is a register, then we want to allow immediate 64. So it looks like that's actually taking care of all of the basic register moves. So now we need these memory access ones, and here we've got C6, 0, 0. So the mod is this. So mod, we should be skipping reg in this case, because C6 was /0. Which indicates that the ModRM byte of the instruction only uses the RM operand. The reg field of ModRM contains a digit that provides an extension to the instruction's opcode, which we OR into the lower 3 bits of the opcode again. Oh, sorry, we don't OR those in. Those are actually still part of the ModRM, but we need to ignore whatever the register number was and use an opcode extension instead. So I think we need another way to say that destination is extending the opcode. So maybe what I'll do is I'll rename this one to say, what should I call this? We should say destination is part of opcode. And then we'll have another flag down here, which will be that the destination reg destination is let's just say reg is opcode reg extension. And this one is not allowed, that one. And then we'll also want to OR in the value of, let's say, opcode extension 0. So this one is just going to be 0, so I could just do ox00, but we'll have some consts so that we can just rely on those. And we'll make sure that what we'll do is maybe say that currently I'm using the nibbles in the value as, you know, let's say we've got ox something, 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 something. Right now, this is the RM. So this is the register number. This one is base. This one is index. This one is scale. We only need 7. We only need 3 bits for the extension. So what we'll do is we'll just put the extension in the 5th nibble here of the value. And so, and then we'll have a function that can shift it out for us into the reg position, I think is what we'll do. So this is now going to be part of opcode. And maybe I'll say is reg part of opcode. Then we've got opcode reg extension. Maybe I'll say reg opcode extension here. And then I need some constants to describe the opcode extensions. So this is 1 to 7, so I can use iota. So this will be opcode extension 0 equals iota. And then we want to shift it up into the 5th nibble. So that will be iota shifted by 16. So we've got 7, 6, 5, 4, 3, 2, 1, and 0. And then where we've got reg as a helper, we'll also need, let's call this reg-opcode extension. So same name as the flag. But this is basically going to shift that value down. So we'll say return byte, which will be the o.value. This is basically going to be 1 higher than the sib, the scale. So let's just take this one here. So this one will be 0, and we want the low 3 bits, so that would be 7. And then we want to shift it down into the reg position, which is 3. So I think if we shift it down maybe by 13, I want to say. We'll try 13. And see how that goes. So if the reg is part of the opcode, we extend the opcode. Otherwise, if the reg is not part of the opcode, we want to change what we're doing with the register field here. So this will be reg. Yeah, okay. So I think in this case we want to say if destination is reg opcode extension, then we'll want to OR in the destination's reg opcode extension, else we'll OR in the reg field, as we would normally expect. Okay, so that took care of a decent amount of them, but we've still got a problem here. This one is saying FF. Have I just done a test wrong? Oh no. Yeah, have I just done a test wrong here? So in this case, I think it's because it's the keyword one. Yeah, because it's the keyword one, I'm actually truncating the value, so it's cutting off this piece here. So this should actually be testing with a 32 bits. And then I think also this one down here needs to test with a 32-bit because it's a memory destination. Okay, so that sorts out the encoding for immediate sources. So the only thing really that I couldn't test very well here is the digits extension for the opcode, because for MOV in this case it's 0. It just doesn't really make any difference. So we'll have to just see when we get to other instructions like add and sub, we'll have to see if that's working properly, but I'm pretty sure it should be okay. So yeah, maybe unless I can think of anything else, maybe next time I'll start thinking of a way to generalize these tests a bit. Right now they're all for MOV instructions, but this is mostly, you know, an RM encoding or an MR encoding, so both operands use the mod RM. And there are a few instructions like that, so there's add and sub and things that I can reuse these tests for, and just skip cases where they don't apply maybe, because there are quite a lot of tests here for different ModR M encodings and things, and SIB bytes and stuff like that. It would be a waste to sort of, repeat these again and again if I can just replace the opcode. Um, so yeah, we'll see how that goes. Unless I think of anything else, that's what I'll try next time, and move on to some other instructions.